A very good evening to all of you who are in India at this moment, and a very good morning, sir, for being here.
Yes, thank you.
I would like to welcome Professor Amitabh Ghosh to be amongst us this evening and many more evenings in this semester. As a matter of fact, the Indian knowledge system is going to um, come up with many things, and this is one of the most important thing, is how we can engage the young minds, young students, into this Indian knowledge system and the richness of it. So this particular course that Professor Ghosh will be coming up with is something which delves deep into the various ancient Indian archaeological as well as astronomical aspects of the system. As a matter of fact, during the ancient Indian studies or anywhere in the world, not in India, it was basically a naked eye astronomy at that particular point of time. So we have to understand that the modern astronomical system should not always be taken into consideration while understanding this. But I must say that Professor Ghosh has written extensively in this area, and I have been a very recent student of his to come up with this particular course. I'm very interested. I'm sure, many other people who are here are also very much interested about this course. And the first year students who are also mandated under AICTE modern new 2024 guidelines will also be taught the various aspects of Indian knowledge system. So we have decided to start up with the this particular course. It will be a completely online course for this particular semester. Maybe the next semester we can come up with some offline courses. So this is about a little brief introduction about what we're going to do. Well, this is a sessional paper. Everyone should be aware of this. And I welcome everyone once again to this very interesting journey with Professor Ghosh with us on the driver's seat. I welcome Professor Ghosh once again. Sir, the course is going to begin, and I hope that this will lead to a lot of interesting understanding of the system, which we generally don't bring on the platter in any conventional education system. So I request you to come up with something very interesting for the young minds and bright minds. I also welcome all the faculty members who have bought their time out to join this particular session. Thank you once again, and I hand over the microphone to Professor Ghosh.
Thank you, Professor Chakravarti, for a very wonderful introduction. It is a very new idea, and as you will realize, that we are going to start a journey which is somewhat very original and unique. So far, such a course has not been offered anywhere in India, and perhaps even outside India. Now, before we start the discussion on the course, I think few things I must mention. One is that the kind of uh, matter content which are suggested or presenting in a course like on ancient Indian astronomy, it is going to be somewhat different in this one. The reason is that the ancient Indian astronomy was, as you all realize, like all other ancient astronomies, was a heliocentric model astronomy and also naked eye astronomy, as mentioned by Professor Chakraborty. So the results and all those matter are really of no scientific value in the present day. Those things are discussed primarily with an objective to understand what they did, what was the error, what was the thinking pattern, all those things. But really, from the point of view of astronomy or science of astronomy, it does not carry much importance in today, because we know the whole astronomy was based on a perceived motion of the planets and everything else around Earth, and Earth was stationary till Galileo's time. So therefore, I think what I have decided, we'll discuss parts of ancient astronomy, but also real astronomy to some extent to make it somewhat more interesting, rather than going into the details of all those Siddhantic texts which have very little scientific value today. But we will definitely discuss a few of those things. Actually, why ancient astronomy is important, I must mention, is for a completely different purpose. I think ancient astronomical descriptions are very important. And to understand those descriptions, we have to understand the system of ancient astronomical science. That is why we'll be discussing this. And why we need these ancient astronomical descriptions, as I will tell, that a very important and innovative technique has emerged, which is called archaeoastronomy. With those descriptions, you can actually identify the era when such an observation was made. So, which becomes extremely important for deciding a chronology and also having a foundation for developing our ancient history. You all know that in India there is one problem, that our ancient scholars, they didn't record history in the conventional way, which is accepted as history by the Western scholar. So they all treat that as simply epics or stories and all kinds of things. So therefore, I think to develop a proper history based on a science-based chronology or time frame, can play very important. That is why I think you will find a discussion on ancient Indian astronomy is important, and actually those things also we discuss. So in this course, we have discussed few, or we have included few things which are not normally considered in ancient astronomical science in India. First of all, we will have some idea and discussion about the real universe in which we are living in, and also certain things like our solar system, our galaxy, what we observe. That, and then we will also discuss something which about the real positional astronomical science. That also we will discuss. And very nicely, you will find you are very fortunate that the University of Engineering and Management has a working astronomical observatory. And Professor Subrata Mandal has planned a series of observational evenings for you, which will be a part of the course. Remember that, not just for fun. So I think therefore our curriculum is somewhat different from the traditional course which you will find in AICT's course content, etc. They are not of much use. They become extremely boring, and I am sure that if I start or anybody start talking about only the Siddhantic texts, uh, very few of you will find it of any value and interesting. So therefore, our program will be where overall, in totality, we'll discuss everything: ancient astronomical science, actual positional astronomy, actual model of our universe and the nature of the universe, and how to utilize the ancient astronomical information for creating a science-based chronology of ancient India, particularly the protohistory. And the Siddhantic astronomy is not very useful because the Siddhantic astronomy is in that period where we already have written history, recorded history. It doesn't help much, because all Siddhantic astronomies happened after AD or in the AD era, and where we already started having from the Buddha's time, we had written, and so not much information is required from astronomy. So therefore, Siddhantic astronomy doesn't help much. What is important is the protohistoric period, epic period, where there is no written history in the regular format. So, therefore, now I think you understand that our curriculum will be a little different from what is suggested in AICT. In my opinion, that is of very little value, and very few of you will find that in this. So, I think what I'll do, I'll share the slides. Most of the course will be based on slides. Only when there will be some little mathematical or other calculations involved, I will set up my webcam and we can have written just like written matter. But most of the time you will find that I will share the slides, and which I hope you will be finding convenient. So as you can see that the title of the course, I don't know exactly what title has been approved by the academic council and the course number. Those things I still don't have, but Professor Chakraborty can include those things in this and I can add it later. So I think first, as I mentioned, introduction to the course and the course outline, which is very important because it is somewhat a different type of exercise which we'll be facing. The course is being offered as a course to the first year or first semester students of engineering, management, law, as per the recommendation of AICT, based upon the Education Policy 2018 of Government of India. The course will be divided into a few sessions, just like your episodes in serials, somewhat it will be like that. And it will be conducted in the online mode this particular semester. And the students can use the following two books as the text for ancient Indian astronomy and for SI astronomy parts. One is History of Science in India, Volume 1, Part 2, which is on astronomy, and it is published jointly by Ramkrishna Mission Institute of Culture, Golpark, and the National Academy of Sciences, India, Allahabad. Another book is Descriptive Archaeoastronomy and Ancient Indian Chronology, which is published by Springer, 2020. The layout of the topics in various sessions is being presented first, so that the participating students can have an overall idea about the contents. And the basics of astronomy will be taught first, so that the subsequent discussions on Indian astronomy and archaeoastronomy can be readily understood by the students. Because if you have some idea about the real astronomy, it will be much easier for you to comprehend what was being done in those days. And this is important as this course does not have any, it has not prescribed any prerequisite. So therefore, it is considered there is no knowledge of astronomy in most of the students, and therefore a discussion on positional astronomy has been included. A background in class 10 level mathematics and science should be enough to follow the course, because there may be many students from law and other branches where science based in the class 12 level was not there. So I think I have designed it in a manner that class 10 level science and mathematics will be given. And the lectures could be in live mode or recorded mode. That means, because of organizational issues may be there sometimes, some of you may have to follow the lecture which has been recorded, and you can listen to it at a later time. But all the lectures will be delivered in live as it is being done. And there, as I mentioned, that there will be direct interaction with the students at regular intervals to clear their doubts and difficulties. So, what will be there? What this course have? First will be introductory comments. First is that why this topic? You have to first realize that you are going to spend your valuable time. What's the point? What's the importance and relevance of studying ancient Indian astronomy? That will be first we will discuss. Then the story of the rediscovery of astronomical knowledge in ancient India. Because India was for a very long time under the rules of those kings and rulers who didn't have much interest in ancient Indian knowledge. So therefore, most of the knowledge of ancient India got lost. And frankly speaking, it is the European scholars came in the 16th century. They started taking interest and discovered all the ancient knowledge in astronomy and many other areas, including astronomy. Then we will discuss the basic structure of ancient Indian astronomical science. That means the whole ancient Indian astronomy can be divided into two major groups. One is pre-Siddhantic astronomy and Siddhantic astronomy. And also, we can have a very quick discussion on astronomy in ancient civilizations, but that is of less importance. We will discuss in a basics of positional astronomy, which is very important. What is positional astronomy? And the solar system and the Milky Way galaxy we'll discuss. the heliocentric system, that means sun is at the middle and we are going around the sun. Then the apparent geocentric model, which rule all the astronomical subjects till the 16th century AD. The very major reference lines like ecliptic, equators, etc. The apparent motion of the sun. Then we will discuss the nakshatra system, which is very important because if you want to study something for time, you need some markers or position indicators. Ancient Indian astronomers used some groups of stars to mark the positions in the sky. And what they did, they saw that moon is taking during its whole journey 27 different positions during a whole month. And these positions are occupied by groups of stars, and they identified those and they called those as nakshatras. They are nothing but the markers in the sky. Later, when I think at the turn of the millennia, in the first century AD, the astronomers started following the zodiacal signs, and the whole astronomy became dependent or based upon the zodiacal signs. Then, of course, the observed periodic motions, and then we'll continue positional astronomy that we'll discuss about the celestial coordinate systems, then deviations from the periodic nature of astronomical parameters, the precision of the equinox, I mean to say, advance of the perihelion position and its effect, precision of the equinox and its impact on positional astronomy, descriptive archaeoastronomy, which is very important. And that is one reason why we should have some interest in ancient astronomical. Because to understand those descriptions and to use for chronological purpose, you have to have some idea about the ancient astronomical science. Then solar and sidereal times, moon's motion, and the eclipses. Then we will start pre-Siddhantic astronomy. We'll go to the Indian astronomy. First, we'll discuss pre-Siddhantic astronomy, which starts from the early Vedic period. So, periods of pre-Siddhantic astronomy, astronomical observations in pre-Vedic period, alignment of important ancient structures, astronomy in the Vedic period, planets, comets, and meteors, astronomy during the Vedanga period, day, month, year, 5-year Yuga concept, and the ancient lunisolar calendar they have developed in India. As you know that, in the West, they follow a purely solar calendar, and the Islamic system, they follow only a lunar calendar. But Indian astronomers realized, though they are all the rituals, etc., based on lunar calendar, but since the solar movement, or the sun's position decides the various, what I'll say, seasons, etc., they knew the importance of that, and so developed a lunisolar calendar. Then will come the naming of the months, how the months were named, which is very scientific in Indian system, which is not so in the Western system. Then seasons, then Mahabharata, Parashara, and Garga, the dark transition period. Then we start Siddhantic astronomy, the possible interaction with Hellenistic astronomy, that means the Greek astronomers, after Alexander's visit to India. The weekdays and the zodiacal signs, the structure of Siddhantic texts, schools of Siddhantic astronomy, the Yuga system and the epoch concept, and the Mahayuga system. Then we will discuss Siddhantic astronomy. Now, Siddhantic astronomy, which will continue, it will be the determination of Tithi and Nakshatra. Actually, you know that in the ancient time, the astronomers initially, they were primarily interested in the motion of the sun and the moon. These are the two most important astronomical objects in the sky, with obvious reason. And their primary interest was the uh, determination of the nature of their motion. Planets gradually started being discovered. As you know, the first early era, the important planets were known as Jupiter and Venus and Mars. the planets like Saturn was added at a later time. And of course, as you know, that the other planets were not known to Indian science. As to at Saturn, we went up to Saturn. So therefore, that gradually, as time progressed and thousands of years of observational data were there, gradually, more planets and more features of astronomical science started being taken up. But at the earliest era, main objective was to study the motion of the sun and the moon. Then, of course, as I mentioned, that determination of Tithi and Nakshatra, because the whole calendar for all kinds of rituals were based on lunar month, which is nothing but lunar day, that is Tithi, and the position is to be decided by Nakshatra. Then mean motion of the sun. Earlier, only the average motion used to be calculated and studied, because you know that this motion of the sun, moon, etc., it is not uniform for various reasons we will discuss. The motion appears, what motion appears, they're non-uniform. And therefore, the technique used to be first you study the mean motion, decide the mean position, and then apply the corrections. There are two types of correction, the Manda correction and Shigla correction. Then we will discuss about Aryabhatta I and his astronomical contribution. Then we will take up, then it was gradually realized that the precision of the equinox, that the whole alignment, whole system of the stars, their position, it slowly changes. It is not fixed. And then, of course, they started realizing that. That means the uh, whole thing is shifting, the equinoctial positions are shifting. And then the concept of zero precision here was there. We'll discuss those. And the major contributors to the Siddhantic astronomy. We'll have a very brief discussion. Because as I mentioned, the Siddhantic astronomy, so much of detail, but the whole thing was based on an apparent geocentric model, which is wrong, of course. And of course, the whole system was a naked eye astronomy. So data was obviously far less accurate compared to today's telescope-based astronomy. So therefore, there is not much information which you can gain. I think we can really utilize now. Then I think we will come to astronomy in the medieval period and the late Siddhantic astronomy, that means the Islamic astronomy, uh, transmission of Siddhantic astronomical knowledge to the Islamic world. Actually, from there it went to Greece. And then astronomy, as you see that even the peculiarity was that the Arabs got the important texts translated in Arabic, and they also got the knowledge from Ptolemy's time. So later, I think again the same thing went to Europe from the Arab country with different names, which we'll discuss. Like, say, for example, Al Majesty. Al Majesty in Arabic means the majesty. So Ptolemy's book was very important because it was a very comprehensive text. And that's why it became known as Al Majesty. It is actually the distorted form of the Al Majesty, and started being called as Ptolemy's book. Anyhow, and then we will also discuss during the medieval period, and the Jaising was one of the major player in that. And the most unfortunate thing is that when Jaising uh, did all his studies and erected all the observatories, by that time already telescope was invented, and Galileo announced that it is a geocentric model is wrong. We are in heliocentric. But the uh, Jesuits, who were all followers of Catholic, they are all Catholic priests, they took all care to keep Jaising not informed about the development and discovery by telescopic astronomy for Galileo. They took all care. So therefore, Jaising was totally unaware about the real development of astronomy after the discovery of telescope. Very unfortunate. And the last Siddhantic astronomer we have is Samanta Chandrasekhar, and from Odisha. Uh, we will have a brief discussion on that. Then we will also have a discussion on the instruments used for naked eye astronomy. You know, their astronomical, the determination, the values, they're pretty accurate. And it is really a matter of uh, great surprise that using the simple instruments, how they got such accurate results. Now, some instruments of the medieval period, astrolabe, which became very popular with the Pathans and Mughals. So they used to be very strict follower of astronomy, you know. So astrolabe was also an instrument which was very popular. We'll have some discussion. And we'll also discuss about Joyce's observatories and the kind of instruments he developed. Then we'll have some final sessions. So that is the epilogue and the concluding remarks. Here we have to discuss things like the antiquity of ancient Indian astronomy. That means it is very important that there is a lot of controversy that in Indian astronomy, how old it is. Some European scholars say it was in the 15th century or 14th, almost Mughal period. And some say it is 3,000-year old. So this controversy, you know, we have to settle. And here, Max Muller played a very important role, and we'll discuss in details. And he showed that many of the things, particularly the lunar asterisms, the nakshatra system, people claim that, you know, they are from China, because China also um, had a similar system, but he proved, and we will also see that proof, that actually it came from India. It was very interesting. Then we will have descriptive astronomy and its application. We will apply these archaeoastronomical techniques to some ancient observations and try to find out how antique or how ancient those observations are. They're very interesting. And actually, that is why there is some meaning of studying ancient Indian astronomy. You can utilize it in a fruitful manner, not just for the sake of curiosity. And some final comments will. Now, as I mentioned, that attempt will be made to restrict all individual lectures to 1.5 hours approximately, or it can be modified to 1 hour lecture for your purpose. The recording will be 1 hour lecture. And so therefore, if it becomes necessary to replay it, it will not create any difficulty, because regular the classes are 1 year, 1 hour. So that arrangement of cutting and pasting those things will be done by Professor Mandal and Professor Chakraborty's team. But those who can listen the lectures, it will be twice a week, 1.5 hours every day, 3 hours in total per week. And the lectures will be based mostly on PowerPoint slides. However, sometimes, as I mentioned, some calculation, some small derivations. Then what I'll do, I'll use a webcam and I'll show you the actual calculation, the way it is done in a blackboard with the help of a laptop. Now, when you have, please do one thing. Don't just listen. Please also, because it's a course, you will have to appear in examination. So please have a notebook on which actually note down your important points, and later you should also note down the doubts or questions you have, so that we can discuss in a suitable manner. And there will be 2 mid-semester examinations and 1 end-sem exam. Professor Mandal and his team, they will organize these examinations. So till now, this is the background of the course which we are going to run in this semester.
Yes, sir, definitely.
So now I think we should start, as I mentioned, the discussion. Why this topic? why it is important and why the country is, or other government or the ministry, they're requesting you to study this kind of a subject or topic. That is something. Let us. Now, one thing, astronomy is one of the earliest branch of physical sciences. It's quite, you can realize that once there was food security, that means you don't have to run around continuously to earn your bread or have your food. That means when agriculture was invented, that means people became stable in a particular location and food used to be under regular supply through agriculture. Then people had a little bit of leisure to really observe the surroundings. Now, of course, you can see that most important thing they notice that the whole every day there is a half the day is there is sun and light, and half the time it is dark, and the sky is full of bright spots. They look like small candles in the sky. And there again, a very important member was there, like the moon. And they also were very surprised to see that moon changes its shape, and it is a periodic phenomena. So therefore, I think people started then taking interest in the sky, because that was the most amazing thing. Even today, you realize that sky or heavens, it is the most our source of all curiosities and most interesting. So there is no doubt that why even in the ancient civilizations, astronomy played a very important role in the society. And many things about the ancient past you can understand by studying the some of the features of the astronomical or other astronomy they developed. As we may discuss it later, but we may not have enough time to discuss other civilizations, frankly speaking. But I think there will be enough, some reference to those things in the books I have mentioned, which you can refer. That I mentioned, এটা বললাম এখুনি, যে অ্যাস্ট্রোনমি সঙ্গে কিন্তু সোসাইটির একটা যোগ বরাবরই ছিল, এখনো আছে। এখনো বাড়ি থেকে বেরোবার সময় ঠাকুমা থাকলে তারা বলবেন, এই আজকে বৃহস্পতিবার বারবেলা আজকে বেরোস না, হ্যাঁ, কিংবা একটা যাত্রা দেখতে হলে একটু পুরানো প্রাচীন পান্থী যারা আছেন, তারপর ওই পাঁজিটা দেখি ওই দিনের যাত্রাটা শুভ কিনা, সেটা কি করে হবে, based upon some conjunctions, alignments of the heavenly objects, celestial objects, like say কোন নক্ষত্র এখন গ্রহস্পর্শ আছে নাকি, এই সমস্ত ব্যাপার আছে। তো কাজেই আই থিঙ্ক দেয়ারফোর আই থিঙ্ক অ্যাস্ট্রোনমির সঙ্গে সোসাইটি লিঙ্কটা আছে, এবং সেটা কি কারণে আছে সেটা একটা অন্য ব্যাপার, সেটা রিলিজিয়নের সঙ্গে কি করে। Actually, in the early days, all the things in the heaven, they look like, that means they are all decided by the God, because they are in the heaven. You can realize that. So আকাশে মানে আকাশটাই স্বর্গ ধরা হতো, পাতালটা তো নিচে, মাটির নিচে। তো আকাশের ব্যাপার স্যাপারগুলো they used to be considered to be decided by the gods and others, and so they had their importance. And then I think based upon certain occurrences which are purely accidental, certain norms were developed, that এই সময়টা ভালো, এই সময়টা খারাপ। এইভাবে gradually it became a matter of importance to conduct our daily affairs in the society. পুজো আর্চা হেন তেন। আরেকটা জিনিসও আছে সোসাইটির সঙ্গে, why it became connected was the harvesting. Now the seasons are dependent on the astronomical alignments. That means sun is in Capricorn, then it is very cold, and sun when it is in Cancer sign, then it is very hot in the northern hemisphere. So that way, the positions on the sky or alignments, they decide the seasons, and season means the harvesting time. So I think since harvesting was very, or rather one of the most important activity, so and that was how to be prepared for harvesting, all those things could be at least could be decided or got at least by some hints of astronomical alignments. And that is another reason why astronomical observations were made very important, because you have to know when the harvesting time is coming, when the rains are going to start, when it will be very cold, etc. like that. So many affairs of the society started becoming linked with the astronomy. Another thing why astronomy is important, as I mentioned, that this is the earliest branch of observational science man started. Day after day, month after month, year after year, centuries after centuries, and even millennia after millennia. And these observations, when they started being recorded, they gave up, they gave uh, the many new ideas. Rather, you see that whole of the most fundamental branch of physical science, that is mechanics, it all evolved from astronomical observation. Therefore, astronomy or study of astronomical features led to the development of physics, led to the development of mathematics. So therefore, the many branches of physics and of course mathematical many branches developed. Primarily, the motivation was development of astronomy. So the trigonometry, many things, in mathematics, they were actually developed primarily to handle astronomical observation. So thus, astronomy is not per se important, but it is also the, I'll say, instigator of the development of many other branches of science, particularly mathematics and physics. Then, of course, we have the important role played by the scientists of ancient India. We should have some idea. You'll see that, this is, of course, and one objective of setting up centers of excellence of Indian knowledge system. What happened, as I mentioned, for almost 1,000 years, India was ruled by the kind of people or rulers who didn't have much interest in ancient Indian knowledge system, and most of the things got lost. So many branches of science, mathematics, etc. So it was not known for a very, very long time that they also like mathematics. It is only the Western scholars, they showed what was the development of mathematics or what kind of development took place. And it went from here, India, to Arab and then to Europe. Like that, so studying the ancient uh, branches of science is very important to see that what kind of contributions were made by ancient Indian scientists. And astronomy is one point and one area where India really made very important. Actually, these things we will discuss later also. The Hellenistic astronomy, that is the Greek astronomers, which is considered to be the most ancient and most original. But it has been found that Indian astronomy is much older and is far more matured in those ancient times. So we will do when we discuss ancient Indian Siddhantic astronomy, you will see that. So therefore, these things came up later after we started studying. Another thing you will find, some of the texts, most of the texts are lost. Only one astronomical text belonging to the pre-Siddhantic era, which ended at 1200 BCE. So that got saved because it was called Vedanga. So since the word Vedanga is there, so it got saved or preserved along with the other branches of Veda, as if it is a religious text, but it is nothing but 49 algorithms for calculation of the mean motion of the sun and the moon. We will see that later. The importance and relevance, as I mentioned, should have an idea. Now, as I mentioned at the beginning, that the concepts of ancient astronomy are no longer valid today, because the whole thing was based upon the apparent motion of the heavenly objects around Earth, and Earth appeared to be motionless at the center of the universe, which of course now all of us we know that is not correct. So therefore, the concepts which were developed, they were bound to be wrong because it was based upon a wrong premise. That means the Earth is stationary and the everything else is moving around. However, studying the astronomy developed by the philosophers and scientists of ancient India revealed the brilliance to today's younger generation. You will see, say for example, Aryabhatta. Aryabhatta is the one, as I will mention later in details, he was the first to show that it is the earth which is spinning, and the heavens motion which we find every day, once every day, is a purely a kinematic relativistic matter. It is a relative thing. He mentioned also that it is just like as if we are on a boat and boat moves. You don't feel your motion, but you find bank along with the trees, houses, everything, it moves in the backward direction. In the same way, it is this earth which is spinning, and we see the whole heaven rotating around us. That he told 1200 years before Galileo. Now, not only that, with naked eye astronomy, he calculated the period of this rotation, which differed from the modern value by only a few seconds, 23 hours, some minutes, and some seconds. I think the difference with the modern value, hardly a couple of seconds or 3, 4, 5. So you can imagine the brilliance of such people. And you can also see that all their subject of the science, how they preserved it, how I think nowadays you all are familiar with the compaction, space. So therefore, they did it that the whole of Aryabhatiam were only maybe 20 or some sloks. So they compacted the information in such a wonderful way. Even today's computer scientists find it absolutely amazing. So I think studying ancient subject, though it may not have been correct all the places, but the brilliance of their minds and their capabilities should be known to our younger generation. This I mentioned, the astronomy acted as the impetus for developing other branches of science, particularly mathematics and mechanics, which I think we may discuss sometimes that how it happened. And one lecture on that maybe will convince you that the whole of mechanics actually evolved. Your theory of gravitation, your laws of motion, everything actually evolved out of the astronomical science. That will be a very interesting lecture, but that is not a part of our actual topic, but we can take it up on some day, suggested by Professor Chakraborty. We can have that as a seminar, which will be very interesting and useful. So as I forgot to mention that this course, we occasionally can have one or two seminars type of lectures also. Maybe one of such lectures, after we proceed little bit, we progress little bit, we can have a lecture that how astronomy gave birth to the science of motion or mechanics. That may be interesting. So I think Professor Chakravarti can find a suitable slot, and we can make it, or we can have it in the form of a seminar lecture. As this I mentioned, the studying ancient Indian astronomy can help in establishing the chronology of ancient India, particularly the proto-historic period, where we don't have a recorded history or a history recorded in the currently acceptable format, which is accepted as history, not as stories or something. So, using the principle of archaeoastronomy, we can create or develop a dependable chronology of ancient India, starting from early Vedic period. Of course, it has to match with the other kinds of dating, like archaeological excavations, then genealogical lists, etc. It should match. It should not be completely something different. So then you can have a confidence on that. Now, this such a chronology is scientifically more sound and dependable, because the whole thing is based upon astronomical observation, and which is a scientific matter, and so therefore people will accept it if you can establish a chronology based upon these astronomical observations of ancient times. You see, now ancient Indian history, as you all know, anybody who studies little bit, our history, ancient history, it's shrouded in mystery and controversy. Somebody says, it's all started at 1200 BC. Somebody says it is 10,000 years old. All kinds of claims and counterclaims, has made the study of ancient India's history a very serious problematic matter. I think Professor Haldar will be agreeing with me that till today there is no generally accepted historical framework. According to some, it started all when the Aryans came 1500 BC, and many Indians will say, no, it goes back to millennia, much before that. We will see that actually the astronomy will help in at least settling many of these issues. And then again, there are certain major problems with study of ancient Indian history and civilization. Whether civilization of in India flourished in the soil of Indian subcontinent or was brought from outside by the invaders is still not conclusively established, and the subject is hotly debated, as I mentioned. Somebody says they came from outside, the language Sanskrit came from outside, and many of the things came from outside, and it was not much before the birth of Christ, maybe 1500 years before. It was not customary in ancient India to record history in the conventional way. I mentioned this. This is another problem. That means, they wrote lots of things in the form of Puranas, epics, etc. Now, when we say that there was no history, but I think it is said that Puranas are nothing but history. I will come to that later. Even the Puran word itself indicates that it is a record of the Purana means old things. That means history. But I think it is not accepted. Another reason why Western scholars find it difficult to take this as a history very seriously. In many places, the descriptions were shrouded or covered in allegorical form. They are presented in in the form of stories like Rohini's story, etc. I will come to those things later. But I think it is the Western scholars themselves have deciphered those allegorical descriptions and extracted the exact or other correct astronomical meanings out of that. That is another very serious problem. Now, since it is generally accepted, scholars and historians, that literature reflects the characteristics of contemporary society and depends in many situations on actual events, quite often historians use such literature for establishing history. That whatever, story, if you read a story written by Sharachandra Chattopadhyay, for example, it actually reflects the society, the custom, the other procedural matters, etc., systems of the then society, which is 100-year old. So similarly, I think even if some story is completely fictional, but it has to depend on the contemporary cultures, customs, and so on. Such. But unfortunately, when it comes to the history of ancient India, the Western scholars refuse to accept the very large amount of literature available from ancient India to have any relation with the real happenings of ancient, and consider such literature not to reflect real events and treat all such literature to be purely figments of imagination. So it has nothing to do. So you cannot develop any historical framework based upon this literature, this material. However, many ancient texts refer to historical events. In fact, quite a few Puranas, like Vayu Purana and Brahmanda Purana, state very clearly that they record history. In the concluding chapter of Vayu Purana, it states, this slok, I'm not reading it because it's very difficult for me. Only I read the translation. When it is translated, this sloka from Vayu Purana means that the learned Brahmana who hears or tells or teaches the old history will enjoy happiness for eternity in the abodes of Mahendra. Anyhow, that means it tells very clearly that the Brahmana or these Puranas, they are actually nothing but old history. The Purana word itself implies history, as you will see. And most Indian scholars and historians also do not dare to oppose the stand taken by the conventional scholars and ignore the huge amount of ancient literature while establishing the ancient history of India. They are completely ignored. They said all stories nothing to do with the real happening. So therefore, this ancient Indian history is a very serious, there exists serious controversies and a lot of mystery involved. But at the same time, you should realize that unraveling or rather developing a correct chronological history of India is essential not only for India's history, but for the rest of the world civilization. Because India played a very major role, central role in ancient civilizations. And so ancient India's correct chronology can also have a lot of importance in the study of the civilizations elsewhere. That's why it is very important. And this matter has not been taken up very seriously. Many of you, I think all textbooks, more or less, invariably will say that Aryans came from the northwest in 1500 BCE. In 1200, they started composing the Vedas, etc. 99% of the school texts, they tell these things, and the mindset of all our students get, uh, rather I'll say, they form based upon that. So that whole thing is actually nothing but a dogma, and it is a hypothesis presented in the 19th century India. And it has a long history. And now only, till I think before India's independence, the things, any opposition to that was not tolerated. Even today, in the West, if you say that Aryan invasion really didn't take place, there was nothing bad. And the subject or the language, etc., they are indigenous, he will be immediately thrown out. People will not even listen to any kind of argument. So therefore, the ancient history of India is a hotly debated subject, and the opinion they differ so widely that I think it is important for at least our future generations to spend time and to do some work so that the correct chronological order can be uh, established, which is acceptable to all. And to do or to make it acceptable to all, you have to base it on very scientific grounds. And astronomy is one of those. Now, as I mentioned, the primary reason behind such an attitude is because of extensive use of allegory in the descriptions of ancient events in such literature. Now, here I think a little bit of discussion is important. Of course, it is considered, rather it is uh, why so much of allegorical texts exist. People are not very sure, but there are certain opinions that people think that in ancient time there was an attitude of the scholars to hide the knowledge from the common man. So even today, I think Professor Chakraborty will agree with me that if you go to a lawyer for writing a document, you'll write it in a manner that very few common man will be able to decipher it. The language is such. So, it in those days, some people think that it is only to keep the knowledge only to a selected group of people, not the common man. Knowledge was not for common man. That is one reason why such allegories were used. Another opinion is that it is very easy to remember a story rather than some scientific knowledge. So, therefore, a scientific knowledge was kept in the form of a story, which is easy to preserve and easy to read, rather than a purely scientific knowledge. That could be another reason why use of such large proportion of allegorical usage in our ancient texts. Now, anyhow, even though the events described in the scriptures and epics may not be taken to reflect real events, there is no reason why the description of contemporaneous stellar alignments described in those texts should be considered imaginary. Even today, for example, if somebody writes a story and suppose he wants to utilize some description of the sky and he says, okay, in the winter time, it is very cold and the hero of the story, he was standing looking towards east and he saw that the Orion, that is Kalpurus, is rising in the eastern sky. That is what actually happens today. But I think in few thousand years later or few thousand years earlier, that was not. Therefore, what even a storyteller writes, what is observed commonly? You will say that yes, there is a pole star or Dhruva Nakshatra in the north direction. If somebody writes, it really exists like that. But after a few thousand years, it will not be there. So I think it is more or less, it goes without any doubt that the descriptions, whether the story or events were imaginary, but the descriptions of the environment, description of the sky and the stellar alignment, etc., they cannot be imaginary. They are what is seen in those days. And that is what I think you can use to find out the antiquity of the description, when it happened, when such an alignment was actually existing for observation. As we'll be uh, as you will be seeing later, Now, I'll discuss that later in details. The characteristic of the celestial sphere, it changes with the seasons. You are all familiar with that. As I mentioned, that the constellation Orion rises in the eastern sky when it is very cold in the northern hemisphere in the month of January or so. Similarly, you can see Saptarshi Mandal or the Big Dipper in the northern sky when it is peak summer. So these are some kind of observations commonly we find which are linked with the seasons. Besides the season sky correlation also slowly varies with time, as you will see, I will show you, due to the precision of the equinox. And that is like that, when you have seen a spinning top, the top spins at a high speed, but the axis of the spin slowly rotates. You must have noticed that. Whoever has seen a spinning top, he has noticed this phenomena. So that slow motion is called the precision. So Earth's axis also, Earth is rotating or spinning 24 hours every one rotation. That is a high speed. But slowly the axis of the Earth slowly precesses like a spinning top. And it takes 26,000 years to complete a cycle. And therefore, this phenomena can function as a timekeeper covering the whole of the late Pleistocene and the Holocene period, with the whole history of all civilizations. Thus, almost the whole history of the modern man and civilization began after that is taken care of by this phenomenon. Of course, there are two other techniques which are used for dating ancient events, like say, for example, ancient total and annular solar eclipses, because these are some rare events, and a total or annular solar eclipse at a particular location, at a particular day of the year, at a particular time of the day is an extremely rare phenomenon. So such observations also are used in pinpointing certain dates, because other things don't pinpoint a date, it only gives an approximate error. And because that kind of a accurate uh, observation with naked eye astronomy is not possible. But I think eclipses are certain events which can pinpoint a date. We will see those things later. To continue our discussion, it has been noticed that the major structures in ancient times used to be constructed keeping a strict alignment with the cardinal directions. Cardinal direction means the true north, true south, true east, true west. These are the four cardinal directions. And when an attempt is made to make a huge, important structure, it was very natural for people to align them not in a haphazard way, but with this, with strict relation with these cardinal directions. Now, like say pyramids, I'll see that. Apart from the many features of such important major structures used to have unique relationship with contemporary stellar alignment. Such alignments are uh, lost due to the precision of the equinox. Studying the, say for example, the major pyramids in the Egypt, they used to be aligned so that they match the exact north. And they decided the exact north by some astronomical observation. Now, what happens? Later it was found that the same method is followed century after century. Slowly, there will be some error, because the method, astronomical method by which you decide the exact north, that shifts and changes. But if you are unaware of that shift and change and take it the contemporary alignment as to be the true north indicator, this definitely this system is going to have some error, and that is what precisely happened. The pyramids of the Egypt, it was found that later those pyramids which are constructed at a later time, they are slightly misaligned with the correct north direction. So therefore, what I'll say that I came up to this, that importance of studying astronomy in establishing a correct time frame of history, ancient history, in cases where history in the normal format is not recorded. So that I have been discussing, and that's one of the very important reasons why we should study ancient astronomy. Not to gain astronomical knowledge, but to develop a dependable historical time frame. That is the reason, which is very different from astronomical knowledge. So what I have been discussing so far is that, primarily the importance of studying this. One should not consider that through the knowledge which we will be studying or that discussing in this course, therefore actual gaining scientific knowledge. No, because all the ancient astronomy were actually erroneous, because it was based upon a geocentric model, which is wrong. Till 16th century or 17th century, geocentric models uh, prevailed the scientific um, circles, and actually opposing a geocentric model used to lead very severe punishment in Europe. You all know the history of Giordano Bruno, because he said that the earth is not stationary. Earth goes around the sun and all the planets. The planets, their light is actually reflected light from sun. And all the pinpointed lights we see in heaven, they're nothing but stars, but very far off. They're nothing but sun. This is the thing which is to teach. So he was arrested. He was tied to a stake in the marketplace. and his tongue was pierced by uh, uh, some kind of, what I'll say, শঙ্কু যাকে বলি আর কি, so that he cannot talk, but his sound can come. And a slow fire was created in which he was burned because he taught these things. So anyhow, so therefore you can see that the whole of astronomy, which was prevalent in the ancient time, was based upon a kinematically relative observation. That is, Earth is stationary, rest are all moving. So our objective in studying the subject of ancient Indian astronomy lies in the fact that, first of all, whatever astronomical development took place, it also led to the development of other branches of science, particularly mathematics and mechanics. That we will discuss later sometime. So that is one important thing. Secondly, even today, the ancient astronomical description can be used in a very useful manner for developing a correct chronology of ancient India, where a formally recorded history does not exist. And there is a lot of controversy. How old is Indian Vedas, etc.? If Max Muller says the Big Veda is 1200 BCE, we accept it. But actually, whether that is correct or not, because it was just a conjecture by one scholar based upon whatever knowledge he had at his disposal. So therefore, there is no scientific foundation behind this kind of dating of ancient Indian happenings. Ancient Indian astronomy study can remove that difficulty to a large extent by giving you a more dependable chronology of ancient India, and which will be very useful in developing a correct history of ancient India, which is not distorted to the extent possible, of course, and which will also have impact on the history of other civilizations. Because in ancient time, Indian civilization played a very major role in even other civilizations around the world. So that is the reason why studying ancient Indian astronomy can be useful even in a very effective manner, not just a matter of fancy or just knowing something because it is our Indian. No, it has a scientific purpose. It has a scientific. And for that, of course, one must have the technique, must understand the technique of archaeoastronomy, but that is not enough. You understand the archaeoastronomical technique, but then to apply it for ancient India, you have to understand and properly utilize the ancient text material. And for that, you have to understand what was the ancient Indian astronomy. Otherwise, the description, you will not be able to understand. So we will go through these things. So therefore, I think today, I think I'll stop here. That means I have come up to this point. That means importance of archaeoastronomy and how it can be. So after that, we will see that whatever other information we get about ancient India from the writings of Megasthenes and others, we'll take up those things also, and we'll try to see that how correct they were or how correct are the modern description by a Western scholar.